Namaskar friends, I welcome you all in this class of structural analysis. Today we are going to discuss the stability of structures. So in the last class we discussed about the classification of structures and its equilibrium, and today we will discuss in detail that how the external and internal stability of structures are checked. Friends, you all know that if a structure is not stable, it is not useful for us, because we are dealing with the load bearing structures, and any structure should be able to bear or take the load without having any appreciable change in its geometry. So a stability of a structure is very necessary. It is very necessary to check the stability of a structure before going to analyze it. Now let us start first with the static equilibrium. So how do you define a static equilibrium? If on a structure a number of forces or loads are acting and the resultant sum of all the external forces is 0, then we call it that the structure is in static equilibrium. Let us see what are the equations has to be fulfilled in the case of a static equilibrium. So friends, you can see that there are two conditions written here for static equilibrium. Sums of the components of all external forces along any three mutually orthogonal axes are equal to 0. It means that sigma fx will be equal to 0, sigma fy will be equal to 0, and sigma fz equal to 0. Sigma fx means that if you take any three orthogonal axes, say in x direction, the sum of the components of all the forces in x direction will be equal to 0. So these are the necessary conditions for static equilibrium. Again, sum of the moments of all external forces about the three mutually orthogonal axes are equal to 0. So sigma mx will be equal to 0, sigma my equal to 0, and sigma mz equal to 0. So this is quite simple, that if you take any structure, there is any body and a number of forces are acting on it. So if it has to be in a static equilibrium, what is the necessary condition? The first condition is that you choose any three orthogonal axes. Orthogonal means that the axis you choose should be in the three direction and having an angle of 90 degree between them. So all these angles are 90 degrees in different planes. You can take any three orthogonal axes. It is not necessary that you have to take in this way only or at this point only. You could have chosen another axis, say at this point and in this direction, but it should be orthogonal. So if you call it x, this will be y direction and this will be z direction. So you choose any three orthogonal, mutually orthogonal. It means that in three different planes it should make the angle of 90 degree from each other. So this is called mutually orthogonal axis. So you have to choose an axis or a system of axis in which the three direction x, y, z are mutually orthogonal. Now if you resolve all these forces F1, F2, F3, if you take components of all these forces in x direction, say in this direction, so the sum of all the components of forces acting on the body in x direction should be equal to 0. Again, the sum of components of all the forces acting on the body in y direction should be equal to 0. Similarly, sum of components of all the forces acting on the body in z direction should be equal to 0. Now the question arises that why it should be equal to 0 for a static equilibrium. I will just explain. Suppose this is a structure or a body in which say forces are acting in this direction. So sum of the forces in this direction, say in y direction, is not equal to 0. So what will happen? It will move in the y direction. So it will not be in a static equilibrium, or it will tend to move in y direction. And the other forces acting on it, say in this x direction, the forces are there in which sigma fx is equal to 0, but sigma fy is not equal to 0. So these forces which are acting on the body, they don't prevent the body to move in the y direction. They will only prevent the body, or they will only stop the body in moving in x direction. They are not causing any movement in x direction, but they are not resisting any movement in y direction. So all these conditions are necessary to fulfill for any static equilibrium. Apart from that, there are other necessary conditions also. What are those conditions? A body is not in a static equilibrium even if it doesn't move, but if it can rotate in any direction, so we will call it is not in a static equilibrium. So neither it should move in any direction nor it should rotate at any point. So for preventing rotation, the moment about these three orthogonal axes, whatever axis we have chosen, x, y and z, the three orthogonal axes, the sum of their moments about any axis, say axis x, should be equal to 0. Again, Similarly, the sum of moments about y-axis should also be equal to 0, and the sum of their moments of all the forces, all the external forces about the z-axis should also be equal to 0. So, all these are necessary conditions to hold a body or to be a body in the static equilibrium. Now, once a body is in static equilibrium, how do we define the stability? Let us come to that. So, let us first discuss the external stability. Now, how do we define the external stability? External stability, as you understand, that for any structure to be stable, it should not move in any direction because of the external forces acting on it. Otherwise, the structure is not good for taking any load. So, the definition is that the structure should not deform appreciably as a rigid body or move appreciably as a rigid body when the external loads are applied on it. So, what are the conditions, necessary conditions for external stability? The necessary conditions are that non-trivial components Fx, Fy and Fz along any three mutually orthogonal axes. It means that to provide external stability, you should have sufficient support, external support, such that they should provide the non-trivial components in the x, y and z directions. If you choose any mutually orthogonal axis x, y, z, then your external support should be able to provide the non-trivial and non-concurrent reactions such that the structure does not move as rigid body. There may be little deformation because of the load in the members of the structure, but these little deformation are very small as compared to the entire dimension of the structure. So, we say that the geometry of the structure has not changed appreciably because of applying the loads. If you apply load on any structure, the deformations take place according to the rigidity of the members of the structure, but those deformations are very small and they do not change the geometry of the structure. But if the body moves as a rigid body because of application of any external load, then we call that the structure is externally unstable. Now, similarly, as we said about the forces, that there should be non-concurrent, there should be non-trivial components in the mutually three orthogonal axes. Similarly, there should be non-trivial couples mx, my and mz about the three mutually orthogonal axes. So, let us understand it, that what does it mean. So for any structure there should be enough restraint these are 3 roller support. So this support will give prevent it in this direction, this will give reaction in this direction, this will give reaction in this direction, and this is going to give reaction in this direction. So we are giving 3 support to the structure. Now for a structure to be externally stable, it should provide sufficient restraint in all the 3 orthogonal directions, say x, y and z. It means that if you apply any load in any of the directions, the structure should not move appreciably as a rigid body to change its from its place. So if the structure is under the external loading, the restraints come from the external supports, and these external supports in all the 3 directions should be able to prevent any movement of the structure appreciably. So friends, we have used another terminology, non-trivial force. It should not be trivial. So the reaction component, what does it mean non-trivial? Let us see the thing in a plane structure. When you come to a plane structure, then only 2 directions are important, x and y direction, because in x and y plane is important, and a rotation can take place in that plane about the z axis. So in 2 dimension, let us take this structure. So what is happening? It is giving a reaction this is x, y and z. So in vertical direction only the reaction components are there. So this is not externally stable, because if you put any force in the x direction, it is going to move, because these components will restrain the body only in y direction. They are not going to restrain in x direction. So it is externally unstable. So for that matter, if you put, suppose the supports in this direction, say in this direction, in this direction, and in this direction, and all these three are parallel. Okay, so they are neither in x direction nor in y direction. So you can say that okay, it is neither in x direction nor in y direction. So it is putting restraint in both the direction, x and y direction. But friends, as I said you that you can choose any two direction mutually orthogonal direction for axis. Even if you don't choose it, if you put a force perpendicular to this direction here or here, so what will happen? If you are applying a force in this direction, these supports are not going to restrain the body, because they can only restrain in its perpendicular direction. So their component in the orthogonal direction, in the perpendicular direction, is 0, and they will not restrain any movement in the perpendicular direction. So the body can move in this direction, and hence it is unstable. So the first thing we found that the reaction component should be non-parallel, unparalleled. The reaction should be non-parallel. Then only this is a necessary condition for a structure to make it externally stable. So maybe one component you can give from this direction, the other component you can provide in this direction, and other component you can provide in this direction, so that all these reaction components should be non-parallel. They should not be parallel, because if they are parallel, you can provide a force in a perpendicular direction to that, and the structure will not be stable. Again, we are saying that it should be non-trivial. What does it mean? It means that suppose for a structure you have provided support roller support at these three places. So this is in this direction, this is again in this direction, but this is not parallel to them, this is in this direction, and this angle is theta. So these two reactions, R1 and R2, and say this is R3. So in the horizontal direction or x direction, if we have chosen this axis as x and y, so in this direction the R1 and R2 are not going to provide any restraint, since they are vertical and they have no component in the horizontal direction. But what about this R3? R3 is going to provide its component R3 sin theta in this direction and R3 cos theta in this direction. So let us see this R3 sin theta. This is the only component which is going to provide a constraint in the horizontal direction. If the angle theta is very small, you all know that if theta is very small, its value will be equal to 0. If the angle theta is equal to 0, its value will be equal to 0. So this will be a very small component, sin theta. Sin theta is nearing to 0. So in that case, if you are putting even a small force in x direction, what is happening, that you require a very big R3, very big reaction component R3 here to resist this small force, because the R3 sin theta should have an appreciable value here, and this appreciable value it should have appreciable value. Since theta is very small and this is nearing 0, then R3 should be nearly infinite to make it its multiplication an appreciable value. So it means that the support R3 should be able to take infinitesimally in large force, which is not possible generally. So this will be a weak structure. This will be a weak stability, because it can resist in the horizontal direction very small amount of force. So this is called weak stability. Now, as you know friends, that weak stability is again not good for our load bearing structures, because if you increase the load or an appreciable load is coming in that direction, then the structure will not be stable, it will break down after some time. So we should not use such structures. So again, weak stability is not good for external stability. So that is why the second condition which we say, the first was that the reaction should be non-parallel. The second, that they should be non-trivial. Non-trivial means that they should not provide very small resistance in any direction. Now let us see another condition. This is a structure and support and suppose the support conditions, we give 3 roller support in these 3 directions. Now you can see that we are fulfilling these 2 conditions. They are non-parallel and they are non-trivial also, because the angle is not very small and the support which we are providing is quite strong to provide any restraints in those directions. So they are not parallel, and the R1 is in this direction, R2 is in this direction, and say R3 is in this direction. Okay, but if you extend, they are meeting at this point O. Now what happens, that okay, we cannot move it in either x or y direction, and for that matter if it is constrained well in z direction, we cannot move it by applying any force in these directions. So that way it is okay. But what happens if we apply a moment or couple in this direction. So when we apply a moment or couple in this direction, now since all these three reaction components are meeting at O, so their moment about this point O will be equal to 0. So they are not going to provide any restraint in their rotation. So even if a small couple will rotate this body in anti-clockwise direction. So it means then again it is not stable. So that is why the third condition is coming, that the reaction component should be non-concurrent. They should not meet at a point. They should be non-concurrent. So if you see in a plane, when we set the two necessary conditions for making a structure externally stable, we said that it should be able to provide enough restraint in fx and fy direction for a plane structure, and then in the mz direction against any couple. If they are meeting at a point, it will not be able to provide this constraint. So if we translate it in these three necessary conditions, they come out to be that reaction components or reactions should be non-parallel, they should be non-trivial, and they should be non-concurrent. Again friends, you must remember that for all these things we should also consider the weak stability, which I said you earlier. In case of a couple or moment, again a weak stability may be there. So we must exclude that option also. Because if you take reactions of these three, as you can see that all these three reactions R1, R2 and R3, they are not meeting at a particular point O, but they are in a small vicinity, at this vicinity. So again this will provide a weak stability against any rotation in this direction, because if you take its component in this direction, so this will be large because of theta, this will be R3 cos theta, and perpendicular to this will be R3 sin theta. So the moment which it will give for resistance will be equal to R3 sin theta multiplied by this distance. Say this distance is d from O. So R3 sin theta into d. Since theta is very small, so sin theta will be nearing 0. It will be very small, and to resist any appreciable couple or moment, the R3 has to be very large it should be nearly infinite R3. So again this is providing a very weak stability, because we cannot have any external support which has infinite restraint. So there will be a finite restraint. Maybe it is appreciably high, but it will be finite. So if you put a condition that it should be infinitely strong, then the external support may break and the structure is not good for stability. Now friends, we will discuss, we have discussed about the external stability, and now we are going to discuss the internal stability. So till now we have discussed that external stability is called when the body does not move as a rigid body in relation to any three orthogonal axes, mutually orthogonal axis which you take, and the movement or the change in geometry of this structure is not appreciable as compared to its dimensions. In fact, if the body is moving as a rigid body, then the change in geometry doesn't come into picture. So for external stability, the body should not move as a rigid body in any direction, or it should not rotate in any direction. And as we said that for a space structure, it should give enough restraints in all the three directions, x, y and z, the force component, and again in all the mutually three orthogonal directions as a moment constraints. So this should be able to provide, then only the structure will be externally stable. What is the concept of internal stability? Friends, a structure may not be externally unstable, it may be externally stable. Enough restraints are there from the external supports which we have provided, but the internally it may not be, the structure may not be internally stable. That means that a part of a structure moves in comparison to the another part of the structure, so that its geometry is changed. So that is called internal instability. So we define internal stability that no part of the structure should or can move relative to another part so as to change the geometry of the structure appreciably. So in this we will see the pin jointed structure and rigid structures separately. So friends, this is a simple truss. If you take here we have provided a pin joint, so it gives reaction components in two directions, and this is a roller joint which gives a reaction component in vertical direction only. So this is externally stable structure, and what we define as internal stability, that no part of the structure should or can change its shape in comparison to another part of the structure, so that its geometry is appreciably changed in comparison to the dimensions of the structure. It means that if you provide any load at any part, the structure may change may deform because of the load, but it is not going to change the geometry of the structure. If we take these changes are very small in comparison to the dimensions of the structure, because dimensions are very large and maybe in meters, and the changes are going to take place, say elongation in this member may take place in millimeter. So that is insignificant or unappreciable change in the dimension. So that is going to happen, but that is not internal instability. Internal instability will be different. It is because of the internal structure of the structure, internal arrangement of members in the structure. So suppose this is a truss, a simple truss in which these are hinges. This is externally stable and internally also it is stable. But suppose we move this link here, we will remove this link from this place. So what will happen? Now, since this is a link and this is a pin joint, so this can, and here also there is a pin joint, so it can go in this direction. And again this point also can come here, and this point can come here. Okay, so this is connected to this point and this is connected to this point. Okay, and this can also come here. So you can see that since this restraint is not here, this we have removed. So because this link is not there, so the shape of this can change. Instead of this, it can come in the other direction and the entire shape can change. So though the structure is externally stable, it has got constraints in 3 direction for a plane, and it is sufficient to restrain it externally for any movement, but the structure is unstable internally. So friends, today we have talked about the stability of a structure, its external stability and instability. We have seen that what are the necessary conditions for external stability, and then we have started the we have introduced you to the internal stability and instability also. In the next class we will discuss the internal stability in detail, and in that we will discuss the pin jointed structure and rigid frame structure, and after that we will discuss about the overall stability of the structure and what are it, how they are ensured in different type of structures. Thank you very much.